Hi, logarithms in other bases, using properties of logarithms to expand logs. So, our lesson is about logarithms and how to use some properties to evaluate the logarithm. So, let's start it. This is the properties of logarithms. We have here log base b and p equal. How much here? We have the product between m and p here. So remember that if we have y expound 2, for example, times y expound 3 or power 3 equal y, I add 2 plus 3 equal 5. So the same thing here, I can put log base b here for m and log base b for p, and we put between them the sum. I add the logarithms. The same thing here, if we have for the next one, if we have y expound, for example, 9 out of y expound 5 equal y 9 minus 5. So I subtract between this power and this power. The same thing here, log the b, same basis for m, and log b for p, but between them I put the minus. Okay, so for this one here we have m expound n. What means that? I have m times m times m times m times any n times. Okay, so this product between m and times. So here we have log base b for m plus log m for base b. Here we have, I can separate this one, log b for m. How many times? N terms. So this term or this property equal n times log base b for m. So the famous, for the next one, for the famous formula to find the value of x or any any now unknown number or numbers. So here the famous rule. If we have log x base b equal log y base b also, so I can conclude that x equal y. Okay, it is useful to solve many equations. So let's continue our lesson to find the key point here. If we have y equal a expound or power x, then x equal log y base a. So here's some properties for this logarithms. Log a base a equal 1 and log 1 base a equal 0. Here we have log a expound or power x base a equal x. I would like to use this one. It is simple, okay, and useful for many cases. So here we have this simple example to convert to logarithm form. So here we have 5 power 3 equal 125. I can change here log base 5 of 125 equal 3. So this formula I can change by another one like that. So here we have log 125 base 5 equal log base 5, but instead to write 125, I write 5 power 3. So the same thing here equal 3. But it is easy to find the value of this quantity. So the same thing here, I can write log 2 of 32 equal log 2 with, instead to write 32, I write 2 expound 5. So here it is easy to conclude that the value of this quantity equal 5. The same thing here, I can write log, for example, of, for example here, 1 out 81 of 1 out 3. So equal here log 1 out 3 of 1 out 3 expound 4. Okay, expound 4 here. So equal 4. Okay, let's move for the next part of this section. We have here some evaluation. Evaluate log 16 by 2. So here I can write here in this place 16 equal 2 power 4. So here log, instead to write 16, I write 2 power 4 equal 4. Same thing here, equal, I write 1 out 9 equal 1 out 3 square equal 3 minus 2, power minus 2. So here we have log base 3, but instead to write this quantity, I write 3 power minus 2 equal 3 power minus 2, or exponent minus 2 equal minus 2. So for this one, it is difficult to use. So let's write 2 here, expound 4 equal 16. I have to change this power to the right side. So I can put here 2, 4. 1 out 4 equal 16, 1 out 4. So here I can simplify by this 4 and this 4. So the 2 equal 16, 1 out 4. So here log base 16 of 2 is right. Instead to write 2, I write 16, 1 out 4 equal 1 out 4. Let's move for the 27 here. 27 equal, I know that 27 equal 3 power 3. So, but I must to have 9 here. So I can change here. I multiply by 2 times 2 and divide by 2, this power. Okay, so we have here 3 expound this 2 here, the total 3 out 2. Okay, it is clear that this one here 3, this line 3, I in the first one we have here 27 equal 3 power 3, but this 3 I can multiply by 2 and divide by 2. Okay, so I can divide by 2 here and multiply by 2. So equal 3x square, the total 3 out 2. But 3 square here equal 9, 3 out 2. This 27. So the last thing here, 27 equal 9 expound 3 out 2. So I can change here log 27 base 9 equal log base 9 also, but instead to write 27, I write 9 expound 3 out 2. So the value of this logarithm equal 3 out 2. So let's move for the next thing here. Come more practice. So here we have log 2 base 8. The same thing, we have here the 2 exponent 3 equal 8. I change this power to the 8, so 2, 3 here, out 1 out 3 equal 8, 1 out 3. So here we have 2, 8, 1 out 3. So here log 8. Instead to write 2, I write 8, 1 out 3. So the value of this logarithm equal 1 out 3. The next same thing here, log, I can separate this one, log, 4 square equal 16. So I can move this power 2 in the 16, it will be 4 equal 16, 1 out 2. So here we have log 16. For instead to write 4, I write 16, 1 out 2. So the value of this quantity of this logarithm equal 1 out 2. The same thing here, this we have 25. So the 25 equal 5 times 5. And this 5 equal root square of 5 times root square of 5 times this for the 5, and the 5 also root square of 5 times root square of 5. So the total 25 equal root square of 5 exponent 4. I can change this 4 in the 25. It will be 25 exponent 1 out 4 equal root square of 5. So here log 25, instead to write root square of 5, I write 25 1 out 4. So here we have the quantity of this logarithm, it is 1 out 4. That's it for today. Thank you so much, guys. Don't forget to subscribe to our channel to receive more content. So keep learning, keep exploring. See you in the next one. Thank you so much. Thank you.